after this, you will know how to subtract vectors. And the real hard part is being able to recognize a vector subtraction situation. In other words, knowing when to do vector subtraction. And I'll give you some rules for that as well. Okay? I've got to talk here for about 25 minutes or so. And you'll have some time to work. And there'll be some clicker questions and a chance to sort of do some of that stuff as we go here. So let's begin. So what do you think subtraction of vectors means? Keeping in mind that addition means placing things tip to tail. What do you think? Any ideas? First thoughts? Gut instincts? Go ahead, Travis. Tail to tip. It's not the same thing? Yeah. Trying to pull a fast one on me? Tip to tip, maybe? Okay, well, what we're going to do is we're going to look at it from a standpoint. Is there one here? We're going to look at it from a standpoint of regular subtraction numbers. Okay? So subtraction of scale numbers can be written as addition, right? You were probably shown this at one time. So for example, I might say 10 minus 6 is the same as what? 10 plus minus 6, right? So I've rewritten the addition, I've rewritten the subtraction as an addition. In fact, I'm adding the, what would you say? Adding the negative or adding the opposite? Right? Would you say that negative 6 is the negative of positive 6? I could give you any number in the world and you could give me the negative, like 17. Minus 17, you just say the same number with the word negative in front and you're gold, right? Okay, so now, what do you think, what does it mean to be the opposite or the negative of a vector? Adam, what do you think? I'm just asking, what do you think it means to be the opposite of a vector? Like, how does that, negative 6 is the opposite of plus 6. What's the opposite of a vector north, we'll say? South? What about east? Okay, I think you got it. So what does it mean? A negative of a vector is simply opposite direction. And there it is right there. The negative of a vector is a vector having the same magnitude. What does the magnitude mean? The size, the number part. But exactly the opposite direction. Exactly the opposite direction. Now, when I say exactly the opposite, well, I mean exactly the opposite. You might say, pull a 180. What does that mean, a 180? 180 degrees. Opposite. Okay, you guys are all on the right track here. That's good. So, for example, if A is to the right, like so, which way is negative A? Left? Just rocket science?
Yeah. Of course.
Arrow science. So far, it's pretty easy. Just think of it as a teenager thing. If I say go right, you go left. Opposite. Mom says do the dishes. You don't do the dishes. You guys should be good at this. Little joke there. If B is up to the right, minus B would be down to the left. Opposite. Okay. What if it's something like C is equal to 0, 1, 0, the bearing 0, 1, 0? What would it be, T? 190, he says. And how did you come up with 190? Mathematically, how did you come up with 190? Add 180, right? You can add 180 in your head. To 10, certainly, right? 10 plus 180 is 190. Some of you might want to do this. Okay, so now if I give you a more challenging question, what if the number's already bigger than 180? What if it's 300? Subtract 180, Josh? So what would you get? Right you are. So the rule is, if it's less than 180, what do? You add it. And if it's already bigger than 180, well then you just subtract. Oh, yeah. Yeah, pull a 180. Hands up if that's hard. Excellent. Last one. What's going to happen here right away? What do you see coming? Clicker questions. So I hope you're listening because you're going to have to answer. What if I give you east vector, or vector E is south 15 east? South 15 east. North 15 west, you think?
Yeah.
South 15 east, right? Would be south and then 15, right? So exact opposite would be? Would that be north 15 west? For sure. How do you do that? Well, you just change south to north and east to west. Like it's that.
Opposites.
Opposites. Come get a clicker. So here's the first question. What is the negative of 10 meters per second east? What is the negative? It's right there. You don't have it. It's right up there on the screen. Yep. See how you did. I'm thinking 100%. Everyone, what do you think? 10 meters per second west. I throw this in minus 10 west, you're kind of doing what? You're kind of doing a double negative. Don't do that. Okay, 10 meters per second east, opposite is? Noah? Noah. Braden needs to listen to me. 10 meters per second west. Okay, here's another one. If vector x is 25 kilometers an hour at north 30 east, what is minus x? I don't mean to put any pressure on you, but this morning's class got 100%. On this question. Here's the theory on how to teach or how to subtract. Put the clicker down, pen down, watch. Here's the theory. Watch up here. To subtract vectors, find the inverse or the opposite of the vector to be subtracted and simply add it tip to tail to the other vector. In other words, flip the one you're subtracting and turn it into addition. That's all it is. Okay? To subtract vectors, find the inverse of the vector to be subtracted. In other words, flip the one you're going to subtract and add it in what fashion? Tip to tail to the other one. Let me show you. Okay? Here's vector A in black. Here's vector B. So minus B would be like that. And then what do? Place them tip to tail. This one is A, which would make this one here our resultant. In fact, what's different from this from the last couple days? There's only one small little difference. You flip. How do you know which one to flip out of? The one that's negative, exactly. You just flip the one that is negative. Okay? This part's relatively easy. It's the recognizing the subtraction word problems that's a bit of a challenge, and I'll go through that with you. Does everyone get this okay? Add the opposite. How do we add? Tip to tail. Okay? Did I take two numbers and add them together here? Did I take two numbers and subtract them? No. In fact, there aren't even any numbers here, and there's a reason for that. Okay? Because as soon as I get you to do something, immediately people just take 10 minus 4, 6. Have you not been listening? Do not subtract the numbers. How about we try one? No. It's right on your page there. If A is 10 meters north and B is 15 meters east, what is A minus B? So I've got 10 meters north. Let's label it. And 15 meters east. So that means that minus B would be 15 meters west. Tip to tail. Right? Opposite of east is? Why opposite? Because it's subtract from where you start to where you end. Resultant. Is it a right triangle? So I can use Pythagoras. R squared is equal to 15 squared plus 10 squared. 15 squared is 225. 10 squared is 100. So R is going to be the square root of? Square root of 325, right? 18. What? Are we done? What do I need to do, T? I need the direction. Where do I put the angle? Where do I put the theta? Where you start. Inverse tan. Opposite over adjacent. Opposite is your 15. Adjacent is your 10. .3, we'll just say 56 degrees. Now how am I done? I'm going to put the what? The answer? The direction. So this would be north, 56 west. How is this different from the last couple days? Vector addition. We flipped it. All I did was turn east into west. That's all I did. Yeah. Because it's a right triangle. Would you get it? If you didn't use the second function tan, you'd have to use a scale drawing, and then you'd have to draw this to scale, right? But because it's a right triangle, you can do this process. Because it's a right triangle. Okay? If vector A is 5 meters per second north and vector B is 4 meters per second west, which diagram best shows A minus B? Okay, let's see how we did. Correct answer? C. A is 5 meters per second north. B is the one we subtract. Don't lose focus. So west becomes east. C. Okay, now here's the hard part. How will you know to subtract? Well, there's a couple different ways. One is if it says subtract. If it says A minus B, then it's going to be, yeah. I got a really poor animation here that I need to fix. So there's vector, well, I guess I should probably draw A first again, right? Okay, so here comes A. Here it comes. There it goes. A. And oh, what did I do wrong? I did go tip to tip, right? But you'll also notice that what if I did negative B? Which way would it point? You get the same thing. Exactly. Right? So negative B is this way, right? So you can think of it as tip to tip if you want. Adam, I need you watching up here. Lunch hour is for socializing. Now we learn. Okay? So how do we know when to subtract? Number one, it says subtract. That's the easy way. Here's the harder one. Okay? This one you're going to have to write down. It implies subtraction because it asks for either the wind or the plane speed or the current or the low speed. Now what do you guys have there? Okay, excellent. So all you need to write down is resultant is plane plus wind, right? If you're talking about a plane and the wind, the result of the plane speed and the wind speed is called the resultant, right? So we would say that R, standing for resultant, is plane plus wind. Does that make sense?
Yes.
Okay. Now what if I ask you for the plane or the wind speed? If I ask you for the P, the plane, you have to take this plus W to the other side and it becomes R minus W. How do we know it's subtract? It's a negative sign. If you're asked for the wind speed, the P goes to the other side and it becomes, how do you know it's to subtract? It says subtract. What if I don't have a plane in the wind? What if I got boat in a river? Boat and current. The resultant is the boat plus the current. Which means that the boat is, take the C to the other side, and you've got R minus C, right? And what's the C equal to? R subtract B. Hands up if this is hard. Noah says it's hard. We should practice some. Try that one. In fact, I think there's two to try, aren't there?
No.
You try the first one, I'll wait a couple minutes, and then I'll do it, and then you can try the next one. Okay, 35 meters north, meters per second north, 10 meters per second east. Which one do I flip? Just the B. Why just the B? Because that's the one with the negative in front. You would have to, yeah, then you're not flipping it, you just leave it like that, right? So this is going to be 10 meters per second west. So 35 north, 10 west. Here's your resultant. Is it a right triangle? It is, so you can use Pythagoras. If it's not a right triangle and you use Pythagoras, what do you get? Frowny face. Because you cannot use Pythagoras on a non-right triangle. R squared is equal to 10 squared plus 35 squared. I can't do that in my head, so that's going to be 100 plus 36.4. 36.4 what? Meters per second. Guys, watch. Don't get lost. Focus. 36.4 meters per second. At what angle? Inverse tan. Opposite over adjacent. Opposite is 10. Adjacent is 35. .9, we'll say say 15 point. No, we'll say 16. So what are the directions here, Travis? Braden? Braden. You're not helping.
Yeah. You add.
No, I just want the letters here.
Yeah, so I was gonna say you
Oh.
add the north.
Yeah,
16.
very good. North, 16 west. Okay? Are you measuring? Did you take 10 squared plus 35 squared?
Yeah.
Yeah? Okay, I'll come by in a second. Okay, try this one here. What speed and direction should the plane take? We are solving for P. Needs to have a resultant velocity. That's your R right there. This is the wind. Hey, what are we solving for? P. What did I have you write down just moments ago? P is equal to R minus W. I showed you that. So what do you write down now? Well, I would actually recommend you do this, Braden. R equals P plus W, because that's kind of like the starting point of everything, the plane and the wind. We're solving for P, so P equals R minus W, and I would also encourage you to write this as well. P is equal to R plus minus W. The plane speed is equal to the resultant speed plus the negative of the wind. And now I turned it into vector addition, and all you got to do is flip and add. So, 100 kilometers an hour at east 30 north. East 30 north, right? Then the wind is at north 15 west, but I have to do what? Flip it. So instead of north 15 west, it's south 15 east. South 15 east, something like this. Okay, you go ahead and finish. Even if you haven't got it done, let me show you the answer so that the people that are done can go on, and then you can get some help with this, okay? Because there is some more practice stuff. So earbuds out. If you got them in, they shouldn't be in that fast. It's like you guys can go 2 minutes without. I go all day without listening to music. I'm sure you guys can last for 2 minutes. Okay? Watch carefully. Just watch. Okay, a plane needs to end up with a resultant velocity of 100. So we know that's our R. The wind speed is 25. We know that's our W. What direction the speed should the plane take? I'm solving for P. P is equal to resultant plus minus wind. I'm going east 30 north. East 30 north. Then at the end of that, I'm flipping this north 15 west. I got to flip that and go south 15 east. South 15 to the east. Now I do it with a ruler and a protractor, right? Okay, so watch carefully here. I'm going to draw my line that shows east. I'm going to get in my protractor. And I'm going to get one that is 30 degrees. Okay. So 30 like that. Kayla, you watching? Okay, watch close. Now, I haven't come up with a scale yet, have I? So 1 centimeter equals, Adam, what did you have? 10 kilometers per hour. So this is 100. So I'm going to have a ruler that's going to be how long? 10 centimeters. And I'm at 30 degrees, right? Okay, and 10 centimeters long. So there's your first vector. You got to draw vectors. You can't just go 10, 100 minus 25. Adam, are you watching? Because it looks like you're talking to Travis. Got to focus. Bar is raised. Stay with me, man. Okay, from there we're going north 15 west, right? No, I got to flip it. South 15 west. Draw a reference line. South 15 west. East, thank you. south 15 east, so right there. Kind of hard to mark up here sometimes. Okay, and I'm going only 2.5 centimeters long, right? What is it? South 15 east, right? 5. How long do I make it? Kaylee, how long should I make it? 2.5. It's a smidge too long. Okay, and then you take your ruler and do what? Connect it, measure it. Okay, so something like that. I should label these. Okay, so this one here was my 100. This one here was my 25. So this is my actual answer. It looks like it's about, about. It's really tough for me up here. About 9.8, we'll say. 9.8 centimeters, which is 98 kilometers per hour. Now, you also need a what? An angle. Where do I measure? You always measure, what did I tell you the other day? You have to measure where you start, and you have to measure from one of the 4 directions. So put your protractor on there like so. You have to measure from east. You do not measure the angle in between the arms. So from east, we're measuring this one right here. It looks to me like about 16 degrees. So that would be east, 16 north. There's your answer. Okay? You can use that as a model for the other practice questions. You should have 4 more, I think, right? Okay, so here, give me 30 more seconds. If you think you need more practice on this, there's 4 questions there. There's a link. There's a QR code. I strongly recommend you get the QR code on your phone so you can see the answer. If you haven't completed the beige sheet, can I borrow yours, Connor? Thank you. If you haven't completed this, you should do that as well. I'd like to mark these tonight, if possible. Okay? That's what's coming through. I need these in. If it's not done today, you got to take it home and get it done. Okay? Hand them in back there in the inbox. We're done with the clicker. Don't pack up. Use your time wisely. Don't just sit there and do nothing and then say, I'm going to do it later, because I know it happens. You leave your book at school and you never do it. Do not pack up. All right, don't wander.